A warm greeting to everyone. I am Akshay Majan from Civil Department from College MIT Academy of Engineering, Adam. Now today we will going to discuss on the topic bridges. So bridges are the vital structure enabling transportation and connectivity across natural and man-made obstacles. They are fundamental to the infrastructure development, supporting economic growth and social interaction. Bridges play major roles for supporting the country's transportation systems. Bridges helps in reducing the traffic on the roadways, like local people's go from the downstreams, and the people want to go or bypass the city crowded, so people take the bridges. From ancient wooden structure to today's advanced steels and concrete design bridges, engineering has evolved remarkably. This presentation explores bridge classification, components, design, consideration like economical span, hydrological factors, load specification, and motorway failures. So now let's go to the classification and the types of the bridges. Based on structure, bridges are classified accordingly. Beam bridges, basically beam bridges are found in cities. Arc bridges majorly used for the railway bridges. Suspension bridges are made over the seas where long spans of bridges required. Then cantilever bridges, same we can find in major cities. Truss bridges are also for the railway transport basically, and based on the material bridges like timber bridges, wooden bridges like steel bridges, concrete bridges, and composite bridges like concrete and steel both combining and making the bridges. Here are the some pictures of the bridges. First one picture is of the beam bridges. Second picture is of the arc bridge, and the third one is of the truss bridges, and the fourth one picture is of the arc bridge. Components of bridge. Let's see the components of the bridges. First, the deck of the bridge. The deck of the bridge is the surface on which traffic moves, transferring loads to the supporting structures. Deck is the road on which the vehicles travel. Piers and abutments. Vertical support that transfer loads to the ground. Piers are the intermediate supports abundant at end supports. Bearings. Devices that accommodate movements like expansion and rotation between the deck and supports. Bearing transfers the load from the roads to the other components of the bridges. Then, most important, the foundations of the bridge. Substructure transferring loads from piers and abutment into the ground with the help of the foundations. Now let's move to the economical span and afflux. What economical span a bridge must have, and the most important, the afflux. What is that afflux? We will learn in this slide. Economical span: the span length that minimizes total construction and maintenance costs by balancing material use, foundation complexity, and labor requirements. Uh, as per the condition and referring to the IRCs, the economical span of the bridge can be determined. The factors affecting the span of the bridge are as follows, like material prices, labor efficiency, site conditions, and foundation costs significantly influence the economical span design of the bridge. Now let's study about the afflux. Afflux refers to the rise of the water table or water level upstream due to the flow and obstruction by the bridge. It must be calculated and mitigated to prevent flooding and structural risks. The rise in the water table must be taken into consideration and then after the height of the bridge should be determined and the bridge should be made. Like high flood levels, HFL, and so there. High flood level means water highest water level recorded during flood events, critical for setting minimum bridge deck elevation and ensuring hydraulic clearance. As I said before, high flood level means when during the flood conditions, what level of the water has been recorded must be checked, and then the height of the bridge and bridge deck should be given. So that refers to the erosion of soil near bridge foundation caused by flowing water, which can determine stability and cause catastrophic failure if unchecked. As the as the columns of the bridge are continuously goes under the movements of water. Some erosion of the soil and must occur, and regular checking of this is to be done to prevent any damages or natural or calamities. One case study is there of BS rivers in 2023. The collapse was linked to the shore, highlights the urgent need for proper shore depth assessments and countermeasures such as riprap and coffer dams. Uh, Breach undergoes various types of loads. Let's study about the various types of loads. Breach undergoes the dead loads, constant weight from the structural components like deck, beams, and fitting essential for baseline designs. Dead loads also refers to as the self-weight of the breach components and itself. Now let's live loads. Live loads are the vehicles on the road which are traveling, like dynamic weight from vehicles, pedestrians, and temporary loads that vary over time and locations. Some of the there are also some environmental loads. External forces including wind pressure, seismic activities, temperature, induced stresses, and water flow impacts. Environmental, as I said, environmental pressures are also acts on the bridges, which may affect the life and durability of the bridges. Load combinations. Design must consider realistic combination and serviceability under various conditions. Load combinations and the design of the bridge must be done taken into consideration of the IRCs uh, for the standard uh, preparation of the bridges. Now let's go through some IRC's load specifications. IRC Class A loading first one. Designed for a very heavy vehicle including military tanks and multi-axle trucks to ensure ultimate strength capacity. The AA Class IRC is made for heavy vehicles load moving on the bridges. Now let's second IRC Class A loading. Standard loading condition for regular vehicular traffic such as cars, buses and trucks, representing maximum expected loads. The class A loading is for the normal public service bridges. RC class B loading, temporary or light traffic loading, applicable during construction phase or situation with light traffic volumes. IRC class B loading is followed when there is low traffic or low movements of vehicles on the roads or in type of the construction phases. Their significance. Following IRC codes ensures bridge withstand expected traffic loads safely and maintain longevity within Indian infrastructure context. Now let's go to some case studies failure of the bridges in India. First, Majarhat Bridge in 2018. Uh, there was a sudden collapse attributed to poor maintenance and structural deterioration, which resulted in the casualties and traffic disruptions. The collapse of the bridge was happened due to poor maintenance and some structural deteriorations. Second, Varanasi flyover in 2018 only. Failure due to design flaws and overloading, as the design was not properly calculated and uh, due to which the failure of the bridge was done, highlighting the issue in construction oversights and material quality control. Some other Let's go to the common causes for the failure of the bridges. Inadequate maintenance, first, poor construction practices, using low quality materials for the construction of the bridges, excessive loading beyond design limits, uh, loading or overloading on the bridges uh, beyond the design limit. And then now, how can we prevent and maintain the bridges lives? So first, regular inspections must to be done of the bridges for their longevity. Systematic assessments identifying early signs of wear, damage, or corrosion to enable timely repairs. If the wear and tears and damages are identified beforehand, we can surely increase the life of the bridges by maintaining them properly. Then structural health monitoring, like using the advanced sensors for monitoring and providing the real-time data of the bridge performance and getting the potential alerts if any issue arises. Non-destructive testing. Testings like ultrasonic testings and radiography enable detection of internal defects without structural harm. Some of the testing like ultrasonic testings should be done regularly without getting any defect to the structure. Retrofitting and rehabilitations. Strengthening older bridges via material upgrades and design modification extends service life and safety. Using the advanced technologies and measures for the retrofitting and rehabilitation of the bridges. Now, conclusion. Key concepts which we gained from the PPT or presentation. We explore bridges classification, critical components, importance of load designs, and a lesson from failures, emphasizing analytical and practical insights. We must also go under sustainable practices such as adoption of durable materials, careful planning for economical spans, and preventive maintenance ensure long-term infrastructure reliance. And let's call to action. Prioritize user safety, rigorous inspections, and adherence to engineering standards to protect lives and investment in India's growing infrastructure landscape. We must be taking care of the bridges on regular basis uh, and following the standards to protect the investments. It's important. Thank you.